Alright, and welcome to graphing non-factorable quadratics. Now, what if we know it's a quadratic that can't be factored? What is the quickest way to graph it? Well, we're going to have to complete the square for both the vertex and the solutions, the roots, the zeros, the x-intercepts. So we're always going to start by completing the square. And this will allow us to actually find the vertex first. So let's just go ahead and write this one out. H of x is equal to x squared plus 10x, remember we leave our space, plus 22. Now from here, how do we create our perfect square? And by now, guys, y'all should be pros at this by using b over 2 squared, where here our b term is 10 over 2 squared, and 10 divided by 2 is, of course, 5 squared, which is 25. So we'll add 25 right here. And remember, to balance out a positive 25, we also have to put a negative 25. Now, at this point, we have to do two things to create vertex form. One, we'll write this as a perfect square, x plus or minus something squared. And remember, it will always be half of your b term. Well, half of 10 is 5. And of course, over here, positive 22 minus 25 will give us negative 3. And we just wrote that in vertex form. Now, what are the benefits of vertex form here? Well, one, we can find our vertex. Okay, it's easy. Our vertex is going to be at this x value that makes this factor, or the positive 5, equal to 0. The opposite of positive 5 is minus 5. And our y value, or our k value, will always be the same, minus 3. We have now completed half of graphing this. We have the vertex. Now from here, remember, to find our solutions, or remember I could call them roots or zeros or x-intercepts, we'll simply set h of x equal to 0, and we'll say 0 is equal to parentheses x plus 5 squared minus 3. And here we're just going to do simple algebra. We get rid of our subtraction first by adding 3 to both sides. We have 3 is equal to x plus 5 squared. And of course, how do you get rid of a square? Well, we take the square root of both sides, and here is where you are going to need your calculator, all right? Because most of y'all, including myself, don't know what the square of 3 is. And the square root of 3 will be plus or minus 1.73 is equal to, in our square root square cancel, x plus 5. Now notice, I'm going to pause this, clean this up real quick. Remember, we have to write this twice. We have to write the positive 1.73 is equal to x plus 5, and we have to write the negative 1.73 is equal to x plus 5. Now notice, how do you get rid of a plus 5? Well, this is the easy part. Minus 5, minus 5. And what is 1.73 minus 5? Well, of course, that's going to be negative 3.27 is equal to x. That's one of our x-intercepts. And here, of course, we still subtract 5. We subtract 5. And this will, of course, be negative 6.73. You just add those coefficients, 1 and 6. Or I'm sorry, 1 and 5 gives us 6 is equal to x. Now notice, we have enough information to graph this. Let me circle everything that we need in purple. We have our vertex, and we have our two x-intercepts, or our two solutions. And let me show you how to graph this. I would start by graphing my vertex first. We know that we have negative 5 comma negative 3. So we'll go to the left, 1, 2, 3, 4, 5, down 1, 2, 3. And here is our very first point. Now what I would ask you to do is say this. Okay, negative 3.27. We know that it's going to be a little bit to the left of negative 3, but not all the way to negative 4. So we can go 1, 2, 3, and just a little bit past it. Okay? And then here, negative 6.73, we're going to negative 6 and then a little bit past it. So let's see, 1, 2, 3, 4, 5, 6, 7. Well, we're going just a little bit past it right there. And now we have graphed our non-factorable solution. Alright guys, pause this video. I've got one more example. It's a special case. You need to know this one. So make sure you watch example 2. Okay, here we have example 2. And we have r of x is equal to x squared minus 5x plus 7. Now I told y'all this would be a special case, but let's start by finding the vertex first. So of course we're going to go ahead and move aside this constant, which is not a perfect square, and we'll do what we've been doing. We will create our perfect square with b over 2 squared. And at this point, man, I would hope that y'all are pros at this. Now remember, my trick for you, turn it into a decimal. What is 5 divided by 2? Well, of course, that's going to be negative 2.5 squared. And when you go to square that, of course, a negative times a negative is a positive. And let's see, 2.5 squared will give us 6.25. 6.25. So we can go ahead and add our new perfect constant, 6.25. And remember, if we're adding a positive 6.25, we'll also have to subtract 6.25. Now from here, we can go ahead and finish this out. We have r of x is equal to, and we take this and we transform it into our perfect square of x something parentheses squared. And remember, you will always do it by dividing your b term by 2. So negative 5 over 2 becomes negative 2.5. Now from here we know that 7 minus 6.25 should give us plus 0.75. Remember, I'm going to keep this in terms of decimals. And from here, we actually have enough information to write our vertex. We're going to see something interesting with our vertex here. We know that our x value makes the factor equal to 0 when it is the opposite of negative 2.5, or aka positive 2.5. And we keep this the same, 0.75. And what would this look like roughly? Well, roughly speaking, if I were to draw this, when my x is positive and my y is positive, I go to the right 2.5, I go up 0.75, and because, here's my vertex, and because this is a positive coefficient right there, we know our graph is going to open up. What do you notice? Does this quadratic cross the x-axis? No. And since it doesn't cross, we would say this has no real solutions. Now technically we could stop there, but I want to show you what does this look like algebraically. So let me pause this, clean it up. Okay, so of course we set this equal to 0, and we have 0 equals parentheses x minus 2.5 squared plus 0.75. And we're going to start by solving for x by getting rid of our addition in this case, so minus 0.75 minus 0.75, and this would give us negative 0.75 is equal to x minus 2.5 squared. Well, recall, in order to get rid of a square, we're going to take the square root. Well, wait a second. Can you take the square root of a negative number? And the answer is no. So if you get to this point and you're taking the square root of a negative number, that is telling you that this does not cross the x-axis, that there are no real solutions. So this is more or less the best we can do in graphing that. All right? Hey, I know this was a pretty tricky lesson, but thank you for making it to the end, and good luck.